Hi, my name is Kim Winston-Jackson, and today I'm going to be talking about approaches to DOM manipulation. And the first question that may come to mind is, why are there so many frameworks and libraries for manipulating the DOM? Well, DOM API calls are expensive, and they're expensive because each manipulation can trigger layout changes, repaints, and reflows. So that means that in theory, if you had 15 modified DOM nodes, that could potentially result in 15 recalculations of all the elements in the DOM tree if you did each modification one by one. And libraries and frameworks aim to make DOM manipulation more efficient. And again, DOM API calls are expensive mainly because of browser reflow. So what are some causes about browser reflow? Reflow can be triggered by adding, removing, or changing visible DOM elements. And it can also be triggered by changing CSS styles, CSS animations, and transitions. It can also be triggered by interactions by the user with the page also. Some techniques for combating browser reflow include minimizing the number and complexity of CSS rules, minimizing the DOM tree depth, and updating DOM elements in batches. And most libraries and frameworks put a lot of emphasis on this last point, updating elements in batch. That's how some of them manage to be very efficient. And the libraries and frameworks that I'm going to focus on in this talk are Google's Incremental DOM, Facebook's React, and Ember. And more specifically, I'm going to be referencing each of their rendering engines. In the case of the Incremental DOM, it's Incremental DOM itself. In React, it's the virtual DOM, and in Ember, it's Glimmer 2, which is a rewrite of the original Glimmer engine from scratch. And these were chosen because they all have very good performance. But before I get into the rendering models for these three, I would just like to briefly talk about why they may be better than libraries like jQuery, especially in cases where you might be creating complex web interfaces and applications. So in jQueries and libraries like it, you write event handlers which modify the DOM. And as you can see, this can quickly become very unwieldy. So with the virtual DOM, the incremental DOM, and Glimmer, when you write event handlers, you're usually modifying some type of state. And that state update triggers a re-render to reflect the current state of the page. And this leads to much cleaner implementations, especially in larger applications. So let's talk about the incremental DOM now. The Incremental DOM is a DOM manipulation library developed by Google. It can be used as a standalone library, but it was really designed to be incorporated into libraries and frameworks, larger libraries and frameworks. And it was designed with mobile devices in mind, and also for devices that have limited memory. So the Incremental DOM is similar to React's virtual DOM, but it doesn't have a second in-memory representation of the DOM, which saves on memory usage. And instead, its diffing algorithm diffs against the real DOM. And so now, let's look at some of its functions. It has 4 main functions. These functions are element close, element open, element void for self-closing tags, and text for text nodes. And this is just a small code sample where if you wanted to render this div containing hello world, it would look like this, and it's very similar to React's create element. And this is just a little diagram to show the in-memory tree representation. The in-memory tree representation isn't necessarily the entire DOM tree, but rather the dynamic elements of the tree, and it's diffing algorithm diffs directly between these dynamic elements and the real DOM, and if an update needs to be made, it patches the real DOM. On to React. So React is a JavaScript library for building user interfaces, and it was developed by Facebook and Instagram, and it's used by companies like Netflix, Walmart, and Airbnb. And React applications are built up by combining components, and it focuses on one-way data binding, and this just simply means that when the state of the application changes, it re-renders the parts of the user interface that were changed. And it does this by using the virtual DOM and only applying the differences to the actual DOM. Also, React allows for JavaScript to be used everywhere, so you no longer need a separate templating language. It uses what it calls JSX in lieu of string templating. And this is another code sample rendering the same div from the incremental DOM example, and here I've just written it in JSX, and also using React's create element. And this is an in-memory DOM tree representation for the virtual DOM. The diffing algorithm determines the differences in the model, and once they have been mapped to the in-memory copy of the DOM, the diffing algorithm finds the minimum number of operations required to update the real DOM, and this results in 2 copies of the in-memory DOM being used during the diffing phase. On Ember's website, it's described as being a framework for creating ambitious web application, and it has been used in creating sites such as LinkedIn, PlayStation Now, Apple Music, and NBC News. And some of the main points for Glimmer is that it doesn't build an in-memory representation of the entire DOM tree. Rather, by way of its handlebars templating language, it can differentiate between the static and dynamic elements on the page. It can then use these dynamic elements to build a tree of streams for use as its in-memory data model. So looking at this code example, the div containing the hello world is being rendered again. And in Glimmer, the handlebars templating language is used to write the div as such. And then after you write the template in handlebars, it goes through a preprocessor where it's converted into a wire format. And this wire format is in turn converted into top-level opcodes using a custom-written virtual machine. And a virtual machine is also used to generate updating opcodes, which includes parts of these top-level opcodes, specifically like this begin here, where you have begin in like 4935. And if we look at this diagram, we can see that Glimmer stores in-memory nodes a little differently than the incremental DOM and the virtual DOM. Instead of storing full DOM-like nodes, it instead stores them as trees of strings that includes, again, these data values, updating opcodes, as well as other data values. And if the current value is different from the last known value in the real DOM, it changes the associated DOM node. So that's all I have for today. So thanks for listening.